Okay, a couple more tidbits on some of the technical details of fiber. One of the next things they mentioned was bandwidth. We had mentioned a little bit about this before. We talked about attenuation, but when we mentioned bandwidth, the bandwidth of fiber is really a product of the bandwidth and the distance, the bandwidth rating of the fiber and the distance it's going. So a fiber that's rated at 500 megahertz per kilometer, if I have a fiber run that's a kilometer long, you'll get 500 megahertz of usable bandwidth. Meanwhile, if it's half that distance, you're going to get 1,000 megahertz. If it's a quarter of the distance, you're going to get 2,000 megahertz. So the bandwidth of fiber is actually a product of the bandwidth rating of the fiber and the distance it's being used in. So it's not one of those that you can just right off the bat say it's blah. It's actually a factor of. And they give you a couple other examples here in the book too, some of the tables, just to give you an idea. I brought this back from earlier chapter where we talked about the attenuation of fiber, reminding you that here's your multimode wavelength, multimode fiber wavelength versus attenuation. As your wavelength increases, your attenuation decreases. So what we're really saying is the longer wavelengths you use for fiber, the more distance you can go. That's why for multimode, I'm typically in the 850 nanometer wavelength, right around here, for short distances. Meanwhile, your single mode, you're usually in the 1310 or 1550. We're usually around here or here for single mode fiber. And that's the reason we can get some greater distances. We have a heck of a lot less attenuation in single mode fiber because of the longer wavelengths. They talk a little bit about centralized fiber. You can almost think of this back as, Mutoa, or you can almost also think of this as fiber to the desktop, if you will. So with this, we're looking at, from our closet, we would normally do copper category cabling out to, a patch panel, and then from horizontal cabling out to outlets on the wall and then the workstation. Well, with fiber optic, I can get rid of this whole rack of equipment and literally go to a passive patch panel. This is a passive patch panel here. What it really is literally just two fiber connectors, and I plug a fiber on this side, plug a fiber on this side, and it couples them. That's all it really is. So with fiber, since I can go greater distances, I have a lot less equipment costs in that respect. I'm just patching it out, and I can run fiber to the desktop relatively easily once I've, kind of found that I need to do that. First talked about it in TSB 72. This has been incorporated into our modern 568C standard. Here they talk about fiber to the desktop. The equipment for this is higher because I have the fiber out to the desktop. I have the special outlet box I need. I have the special outlet jack I need. But that's one of those, in the future we may be doing more of this. And my structure is going to look more like this, where I'm literally going to have fiber out to just a patch panel out to a workstation. I don't have other equipment here. So in that respect, less equipment, a little bit easier to deal with, but the cost of all these pieces is more expensive. And I might need to worry about fiber to copper conversion too. Thinking about, unless my computer has a fiber NIC in, I would still need to convert that fiber connection at the wall into a copper connection for my NIC. There might be a day that we have fiber NICs in our computers by default. When I'm installing fiber, we mentioned this before, I'm going to install it into interduct or raceway, some kind of cable tray to support it. And here is some interducts. I've used these pictures before. It kind of reminds you of like an orange swimming pool hose. And when you buy it, you typically get it with a rope already in place that I lay this interduct up in my cable trays, install it in my cable trays, and once it's all there, I carefully tie the fiber onto here. There is special pull eyes and everything else that I can use that kind of cradles the end connector, and I carefully pull it through this interduct. So it gives me protection, but it also gives me a low friction, easy path for installing my fiber. It's typically installed in these interducts and raceways for protection. The other thing that was mentioned back here is I usually need to, up here. I usually need to allow some extra fiber at each of the termination points. That way I can carefully uncoil it to work on it, And I also have a little bit extra if I need to re-terminate my fiber. Any connections or connector changes or any kind of breaks, I can cleave that off and re-terminate the fiber. Testing, I actually need a whole separate cable tester to test my fiber. I actually need a we actually haven't gotten into too many different testers yet. We'll get into that when we do certification. But as we start looking at meters, I actually need a meter with a fiber port on it to be able to test it. And a lot of times what you end up with is a meter for copper and a meter for fiber. But some manufacturers do make adapters that I can basically unplug the copper port and plug the fiber port in on the meter, and then I can plug my fiber cable into it. But I still would need to buy that module for my meter. In this case, I'm going to inject a light source into one end of the fiber and test its strength or signal strength on the other end of the cable. So it does need to be a special meter to do this. They remind you here, with some of our wavelengths of light, I might not actually see it. It might be beyond my visible range. So I'm not going to look into the end of the fiber. That's a bad habit to be in, because that light source coming out could be in a range that is laser that could actually do damage to your eye. So we would need to kind of remember that when we're dealing with fiber optic. A couple other things with cabling. We mentioned this before. There is different types of fiber optic cable out there, especially for outside installation. They do make aerial and they make underground. We mentioned this before. Aerial actually has that steel cable in. This anchors to the telephone pole, and the fibers themselves kind of go along for the ride. So the steel cable is anchored to the telephone pole, and the insulation here is connected down, that there's a bundle here of fiber optic cables kind of going along for the ride. The steel cable supporting all the weight. The fiber optic cables are being slung underneath, if you will, supported underneath. So that would be typically what you find on telephone poles for things like your Verizon, Fios, and Comcast, fiber optic connections, those sorts of things. Meanwhile, if I'm doing any kind of underground install of fiber optic, I'm typically going to have armored fiber optic cable, where there is actually a metal shield around here to protect this cable from the ground moving. The ground freezes and thaws. As it does, it starts moving. And if I have a very fragile fiber in there, it could actually break the fiber. The ground freezing and thawing and heaving and moving could actually break the fiber optic cable. So the armoring's there to give it protection from things like that. It's also there to give it protection from critters chewing through it. Typically, I'm going to find in here a gel that's installed as well. I think I have it back here, Icky Pick. It kind of reminds you of like a toothpaste. That's there to keep the critters from chewing through. As the critters start to chew into it, they get a taste of that gel and they're like, icky, and run away. That's why they call it Icky Pick. I know. I'm not making this stuff up. That's what it is, okay? You just got to kind of laugh and go with it, but that's what it is. That's the gel there to keep the critters from chewing through it. And we also mentioned, when I'm dealing with cabling, we mentioned before plenum and riser rating, that sort of thing. Outside, it would need to be UV light rating. The actual insulation itself needs to be UV rated so the insulation doesn't break down over time. Dealing with fiber, I do have some safety concerns. I do need to wear safety goggles. And actually, there are some special ones that, with a laser light source, the lens on it is going to block that laser light source from hitting your eye and doing damage to your eye. So they actually have some of those too. But the main reason is for any kind of, when you're terminating the fiber, the little fiber stubs coming off and those sorts of things, I need safety glasses to protect. I do have some chemicals I'm working with. There is some flammability concerns when I'm terminating. I'm using alcohol and acetone and those sorts of things. So I need to keep that off of me. When I'm terminating fiber, I do have tiny splinters that can come off of the fiber as I'm cleaving and terminating. So one of two things. A lot of the modern tools now actually have little kind of trays in them. When I go to cleave, it catches those fibers, splinters, if you will, so they don't fly around. But the other part too is, if you do have them around, you typically have tape on your desktop that will catch that, or you can put those shards on. But I have to be very careful of those little, as I'm cleaving the fiber, those little stubs of glass that come off, because that could be like a splinter in your finger, and a clear glass splinter in your finger is very dangerous because you cannot see it, and you can't just grab a hold of it and pull it out because you can't see the thing. So they talk all about when you're dealing with fiber, safety glasses for your eyes, using those special tools that catch the cleaved fibers off, and then using special tools that would handle the fiber correctly. And if I do have any kind of splinter in my finger, there is special tweezers I use to pull it out. Plastic coated ones, not metal ones. Metal ones will just shatter it. Laser safety, again, my light sources can actually do damage to, some of my light sources can do damage to your eye, so you need to be very careful not to look into any ports that are for fiber optic that can do damage to your eye. And there is even special laser safety goggles that I can use. All right, last when we come back, we're going to start talking about some of the problems or limitations of fiber.